Hello friends, I am Professor Swanan Nogre, and in this video I will show you how the current meter is analogous to short circuit and the voltmeter is analogous to open circuit. Friends, short circuit means ideally zero resistance and open circuit means ideally infinite resistance. So if you consider the resistance between two terminals of current meter is nearly zero, ideally it should be zero, and if you consider the resistance between two terminals of voltmeter, it is ideally infinite, practically it is very high. So let us first consider how current meter is analogous to short circuit. So let us consider a simple circuit. You are having a resistor of say 1 kilo ohm and which is connected across the battery of say 10 volt. So this is the simple circuit. In this circuit, the current flowing through this circuit is nothing but I is equal to V divided by R. What is V? 10 volt divided by R, it is 1 kilo ohm. So it is 10 divided by 1000, that is 1 by 100. So it is equal to 0.01 ampere. Hence this current I is equal to 10 milliampere. So this is the theoretical current which is flowing through this circuit. Now if I connect the current meter to measure this current, we know that current meter is always connected in series with the circuit. So to connect that current meter in series with this circuit, I need to break this circuit. So I will break this circuit here and connect here a current meter. Now if this current meter is having its own resistance which is very high, what will happen? This resistance will be added with the actual resistance of the circuit and the total current will now decrease. It will not remain 10 milliampere. It will be even less, very less. So that is why if you see the structure of current meter is actually a moving coil galvanometer which is having a very small resistance in parallel with it. So if you consider the structure of current meter, it is actually a moving coil galvanometer having very small resistance in parallel with it. This resistance is nearly equal to 0, not 0 but nearly equal to 0. So if you connect this current meter now in the circuit to measure the current of same circuit, say it is having 10 kilo ohm resistor, then there is potential difference of it is 1 kilo ohm resistor, then there is potential difference of 10 volt. Now if you connect this current meter in series with this circuit, what will happen? Almost all current will flow through this parallel path because it is having very small resistance. So that is why the actual current will not be affected. Very small amount of current will flow through this moving coil galvanometer which will be sufficient for the deflection of it, right? So this is current meter. Now if you consider anything, we have seen that anything in parallel with short circuit is nearly equal to short circuit. Means if I consider, say there are two resistors, say R1 is say 0 ohm and there is R2 which can have any value. So what will be the equivalent resistance parallel if you connect them in parallel? So it will be equal to R1 multiplied by R2 divided by R1 plus R2. So that is why it is 0 multiplied by R2 divided by 0 plus R2. Now 0 multiplied by anything, it is equal to 0. So that is why the equivalent resistance will be 0. As current meter is having very small resistance in series with it, right? In parallel with it, in between two terminals of current meter, the equivalent, the resultant resistance is nearly 0. So that is why current meter is analogous to short circuit. Now let us see voltmeter. If you consider voltmeter, let us consider same circuit. If you are measuring the voltage which is appearing across 1 kilo ohm resistor and which we have connected across this supply of 10 volt, right? So what is the theoretical voltage which is appearing across 1 kilovolt resistor? It is 10 volt. Now if you want to measure this voltage across 1 kilo ohm resistor, the voltage, to measure the voltage, the voltmeter is connected in parallel or across the component. So here I'll connect the voltmeter, right? If this voltmeter is connected here, right, The current which is starting from this 10 kilo ohm resistor, when it reaches to this junction of resistor and voltmeter, some part will flow through the voltmeter and some part will flow through the resistor. Now see, there is the current which is flowing through 1 kilo ohm resistor, it is not now 10 milliampere. So that is why the voltage drop will not be the 10 volt across 1 kilo ohm resistor, because some current is flowing through the voltmeter, some current is flowing through the voltmeter. So that is why in this case the voltage drop across the 1 kilo ohm resistor, it will be less than 10 volt if this voltmeter is having small resistance, right? Now if you consider the structure of voltmeter, voltmeter is actually moving coil galvanometer in which there is very high resistance in series with it. There is very high resistance, ideally equal to infinity, in series with it. So this is the equivalent circuit of voltmeter, and if you connect this across the original circuit, right, so what will happen? Now there are two paths for the flow of current, one through 1 kilo ohm resistor and second through voltmeter, but voltmeter is having very high resistance, right? So that is why almost all part of this current will flow through 1 kilo ohm resistor, which is nearly equal to 10 milliampere, and very small amount of current will flow through this voltmeter and its resistance. So that is why it will not affect the operation of circuit. Hence the voltmeter is analogous to open circuit. Now friends, let us consider you are measuring the voltage. Say you are measuring the single phase AC voltage. There is phase and there is neutral. In between phase and neutral, the potential difference is 230 volt RMS. And if by mistake, instead of putting your DMM on voltage mode, if you put it on current mode and measure the voltage, what will happen? Can you imagine? See, you are putting the DMM on current mode, so that is why the resistance between two terminals of that meter will be now zero, nearly zero. And if you put those terminals here, what will happen? You are directly shorting phase with neutral. So in that case, here DMM will be damaged. If it is having fuse, phase will be damaged, and if it is not having any fuse, the total DMM will be damaged. So that's all about the current meter analogous to short circuit and voltmeter is analogous to open circuit. We'll verify the resistance of current meter and resistance of voltmeter practically. Friends, here I am having two digital multimeters. So left one is yellow and right one is black. Now what I am going to do, one of this multimeter I'll treat as a testing equipment. So left one, that is yellow one, I'll consider, I'll use it as a voltmeter or current meter, and on this black meter I'll measure the resistance of the voltmeter or the current meter. I'll show it to you. Friends, if you consider this yellow meter which I kept on voltage mode, so it is on voltage mode, and this red probe is inserted in voltage port, black probe is in COM, so it is acting as a voltmeter. And this second meter I am using as a resistance meter, so it is on 20 mega ohm range. Currently it is on 20 mega ohm range. Now what I done here, I am measuring the resistance of this yellow meter, that is the voltmeter, with the help of this black meter, that is resistance meter, and you can see that its value is near about the 8.88 mega ohm. 8.88 mega means 10 raised to 6, so it is very high. So it shows that the voltmeter has very high resistance. Now let us consider the next case. In this case, what I have done, this yellow meter I have kept on the current mode. You can see here the red probe is inserted inside the current mode, and this meter is on, selector switch is on current, and this second meter, it is on resistance mode, and you can see the current range of resistance is 200 ohm. What I have done here, I am measuring the resistance between two terminals of this current meter, and you can see that it is near about 2.3 ohm, which is very small, nearly equal to 0. It shows that the current meter has very small resistance and it is analogous to short circuit. Now friends, you can check this current meter with the help of continuity mode of second meter, that is black meter. So what I have done, I kept this current yellow meter on current mode, you can see here, and this second meter, it is now I am going to put on the continuity mode, right? So it is giving sound, continuity sound, buzzer sound. It indicates that there is very small resistance between two terminals of current meter, so that is why we are getting this buzzer sound. So it shows that the current meter is analogous to short circuit, or it has very small resistance. Thank you.